This is the outline of section 10.1, tangents to the circle. First off, circles are named by their center. For example, if I wanted to name a circle, circle P, that signifies that the center is at point P. Radius is the distance from the center to any point on the circle, so therefore all radii are congruent. Congruent just means two circles that have the same radius, and diameters is the distance across from the circle through the center. A chord is different. A chord is just any segment whose endpoints are on the circle. For example, PS is a chord. PR is also a chord. PR is also a diameter because it goes through the center of your circle. A secant is a line that intersects my circle in exactly 2 points. For example, line J would be a secant. A tangent is a line that intersects my circle in exactly 1 point. We're going to spend more time talking about tangents because they generally hold more properties. Example 1, tell whether the line or segment is best described as a chord, secant, tangent, diameter, or radius. AD goes through my center and goes from one end to the other, so it's the diameter. CD is a radius. Line EG is tangent because it intersects my circle in exactly 1 point. And line HB is a chord because its endpoints are on the circle. Tangent circles are two coplanar circles that intersect in exactly 1 point. A concentric circle are coplanar circles that have the same common center. So this blue one on the left are 2 points of intersection. The red circles on the right both have exactly 1 point of intersection, so they are known as tangent circles. And the green ones in the middle have no points of intersection, but then I also have concentric circles in the 1 point. Common tangent is a line or segment to two coplanar circles. A common internal tangent intersects the segment that joins the centers of two circles, and a common external tangent does not intersect that segment. So for example, A, C and D are my two centers of my circle, so if I draw a line between them, okay, so I draw a line between them, lines J and K are internal tangents because they cross over that line. Versus in part B, A and B, I draw my segment between those two centers of a circle, but lines M and N do not cross over that line, so they are external. Interior of a circle are points that lie inside the circle. Exterior of a circle are points that lie outside my circle. Given the center and the radius of each circle, describe the intersection of your two circles and describe all common tangents. Well, the center of circle A, so circle A center is at 4, 4. Circle, oops, I don't know why I wrote it like that. Circle B center is 5, 4. The radius for A is 4. The radius for B is 3. The two circles have only 1 point of intersection, and it's 8, 4. The vertical line, x equals 8, is the only common tangent. That's basically all the information that I know. Points of tangencies are very important. It's the point at which the tangent line intersects the circle to which it is tangent is the point. Theorem 10.1 says if a line is tangent to a circle, then it is perpendicular to the radius drawn to that point of tangency. So if Q is my center of my circle and P is my point of tangency, then they, between the radius and that line, form a 90-degree angle. Okay, converse of that, in a plane, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to it. Tell whether EF is tangent to circle D. Well, I would simply use the Pythagorean theorem and see if this is truly a right triangle. So I want to see if angle E is right. So does 11 squared plus 60 squared, does that equal 61 squared? 11 squared is 121. 60 squared, 3,600. 61 squared, 3,720. So therefore, yes. Okay, so this does work out. So that means that EF is truly tangent to circle D. You are standing at point C, 8 feet from a grain silo. The distance from you to a point of tangency on the tank is 16 feet. What is the radius of the silo? Well, because I know it is tangent, I know that this is a right angle. Okay. So then I can just use the Pythagorean theorem. So I know r plus 8 squared plus r squared, equals r squared plus 16 squared. Foil this side out, I get r squared plus 16r plus 64 equals r squared plus 256. Now what's nice is your two hard squares on both sides cancel each other out. So then I get 16r equals 192. So r equals 12. And since it's a word problem, I must use units. So it's going to be 12 feet. Theorem 10.3, if two segments from the same exterior point are tangent to the circle, then they are congruent. So if SR and ST are both tangent to my circle P, then that means ST and SR are congruent segments. We won't fully work through the proof, but I just want us to realize that this is true. So SR is tangent to circle P at R, and ST is tangent to circle P at T. I know that PT and PR are both congruent because they're both radii. They both form right angles, and then they both share this side of SP. So if I did the Pythagorean theorem on both triangles, then that would clearly show that SR and ST have to be the same measure. And the last problem, AB is tangent to circle C at B, and AD is tangent to circle C at D. Find the value of x. Because they're tangents, you set them equal to each other, so x squared plus 2 equals 11. So x squared equals 9. So x equals positive or negative 3. Now, x can be positive or negative 3 because x is not a length. So they both work. This is a summary of section 10.1.